So today we're going to start looking at something called systems of equations. So the point where two lines or curves cross, and actually most books say cross, and I'm going to change this slightly because it's a bit of a misnomer. We're going to change this to this. This is a better definition. The point that two lines or curve have in common is called a point of intersection. To intersect, they don't actually have to cross one another. They just have to touch one another. You don't have to go all the way through to be an intersection point. So it's just a point that they have in common. So two or more lines or curves is called a system of equations. So we've graphed both of these. Hopefully your graph looks like mine, or at least reasonably so. And you put arrows on the ends of the lines and all that kind of good stuff. The point of intersection, and label its coordinates, is right here at coordinates 2, 2, right? Yes?
Teacher, please pardon this interruption. High school students, we have SBA in building 4 and lunch will be provided. Thank you.
What's significant about this point? I'll take any suggestions that you have, any thoughts. Why is that one important? There's a couple of different things you could say. You want to take a crack at that? Yeah, Ben.
The point where it's because the point where they're the same.
Who are they?
Where the two lines are the same.
Okay. So how about let's say it a little bit different? Is that okay? What if we said it's a point that's on both lines? Okay, but you're right. It's the same for both lines. So this is a point that is on both lines. And in this case, are there any other points that are on both lines? No. In this case, it's the only one. I'll say it's the only such point. If you have curves, they may intersect in more than one place. But with lines, and this is one of the things that when you get to geometry you'll study, is that if lines intersect each other, they can only intersect once. And that's because lines are straight. If lines were curved, then they might intersect in more than one place. All right. So let's take a look at these. So the meaning of a point of intersection depends on what the graph is describing. We're going to look at each of the graphs below, and we're not going to write out the story, but we'll come up with a story that describes the information on the graph. We will write, though, a sentence explaining what the point of intersection represents. So I'll do the first couple, and then I'll have you do the next couple after that. So for A, what this graph represents is the time of the year versus the temperature. And the point in Rio de Janeiro and in San Francisco. So it's showing you those two different graphs. The point of intersection here is the time of the year where the temperature in Rio de Janeiro and San Francisco is the same. It's the only time when they have the same temperature. So the point of intersection will always start that way. Is the time of the year in spring temperature in San Francisco is the same as it is in Rio. Why aren't you writing this?
I already wrote it.
You already wrote this sentence just like I'm writing it right now?
I wrote it shorter, but it has the same information.
Okay. Read me your sentence, please, sir.
The point of intersection is the time of year in spring when the temp meets.
That's not good enough. I'm sorry. You need to write all of this, please. It doesn't have all of the information. All right. So let's look at this next one. So we're looking at a graph. The horizontal axis tells us the number of tortillas manufactured. And this is the cost to produce. And one of the things that drove me crazy about this one is they left off part. It's the cost to produce per tortilla. Please add that on. It's the cost to produce per tortilla. If that's not in there, then they're saying you can make as many handmade tortillas as you want and it doesn't cost you any more if you make more. Right? That doesn't make any sense. So here, the point of intersection is the number of tortillas manufactured when the cost to produce per tortilla is the same for both handmade and machine-made tortillas. Before we go on to the ones on the back, so if you've already flipped it over, go back, please. I'll only ask nicely once. Let's talk a little bit more about this one. Why do you think it is that the machine made, it costs you more per tortilla at first than it does later on? You haven't thought?
Machines got more common and like easier to make and easier to come by, so you didn't have to pay as much in order to get it because it wasn't as hard. What?
So, I agree with you. Over time, that's probably true. That, once upon a time, a tortilla machine was, an incredibly rare and expensive device. But this particular thing doesn't have time involved. So I think you're right that over time, the machines got less expensive and better. But that's not quite what this is doing. Do you have a thought?
Because if you're buying a tortilla machine to make like one tortilla, of course making one by hand is gonna be easier. But if you're making like thousands
Okay, I think that's exactly right. If you buy a tortilla machine and you only make one tortilla, you've paid a lot of money for that machine to make one tortilla. You could have made it cheaper just by hand, right? But over time, if you make a whole bunch of them, eventually the machine is going to be faster and be able to make them less expensively. Okay? All right. Now let's go on to the back. Please see if you can write an explanation for the point of intersection for these two. Feel free to talk to your partner. If you're done, check with your partner, see if they agree with how you wrote it. Some of you are already doing that. Thank you very much. If your shoulder partner is not here today, feel free to join a group nearby you.
Point of intersection is when the angle and cross them at the same point.
Who is your shoulder partner?
Oh, I thought I said properly.
Is where the tortoise and the hare at the same distance from the spelling line at the same time. Always starting at the spelling line.
I must have.
Does anyone need a little more time to write what they're writing on theirs? If you don't have something, you better get something. I'm going to call on people at random in just a moment.
Except when I put the point of intersection, it shows when the tortoise and the hare made it the same distance and ended up between.
What did you put for the first one?
The point of intersection shows when customers ended up the same amount of population information.
Anybody need any more time at this point? Everybody happy with what they have written? Some of you don't have anything written down still. I don't understand that. Okay, somebody's not taking care of their partner. Let's do that. I'll give you another minute. Go. If you don't want help, I'm happy to call on you and embarrass you. I really am. But take the help.
It also shows how the hair passed through tortoise. Which is calm. It also shows where the hair passed through.
All right, let's see who's going to go first. Johnny, tell me what you wrote for C, please, sir.
The point of intersection is when Denver and Boston had the same amount of pollution.
Close but not quite. You've left off the bottom axis entirely. What is the bottom axis?
And population.
Okay, I would take that. It's the time at which Denver and Boston had both the same population and the same amount of pollution. I wrote it a little bit differently. I'll show you what I wrote. I wrote the point of intersection is the population of, is when, the population of both Denver and Boston, is the population of both Denver and Boston when their pollution was the same. But yeah, their population was the same at the same point that their pollution was the same. Good. Okay, so make sure you have both of those in there, all right? And let's see, who's lucky contestant number 2? Number 3, there's no one sitting there, so I guess it gets to be me. So the way I wrote it is this way. The point of intersection is the time at which both the tortoise and the hare were the same distance from the starting line. Something like that. Anyone have any questions about how they wrote it and whether or not it's acceptable as, full credit for the answer? Do you have a question, Emma? Okay. Then let's go on to this last bit. So Gail and Leslie are riding in a friendly 60-mile bike race that started at noon. That's a long ride.
Can't do 60 miles on a bike.
Yeah. Have you ever heard of the MS-150?
Yes.
So it's not a race, but it's a ride that goes from Houston to, I think, Austin or somewhere thereabouts. It's 150 miles and you do it over the course of a weekend.
My sister tried to do it, but she gave up on Saturday.
Yeah, it's not easy because typically what happens is that you have other people that are helping you out that have, set up a tent for you, that kind of stuff. And it's to raise money for the Multiple Sclerosis Foundation. So, yeah, it's hard because you get into the real, not super, it's not mountains, but it's hilly, and a lot of times it's windy, which makes it really hard. All right, so the graph below represents their progress so far. So the race isn't over yet, but, so, what does the intersection of the two lines represent? I'll take a volunteer for this, or I'll voluntold somebody. Yes.
The point of intersection represents
Okay. So, yeah, it's where their time and their distance in miles, the distance that they've ridden, is the same. At this time, they have both ridden exactly the same distance. So, in terms of actual looking at it, what does it look like? Well, they're in the same place at the same time, right? At approximately what time did Leslie pass Gail? Yeah, it looks like it's about 2 o'clock.
Go, Leslie.
But I want you to notice something. Well, we'll talk about it in a moment. About how far had Leslie traveled when she passed Gail?
20 miles.
Around 18.
Yeah, I'd say it's probably 18, 17, somewhere around in there. It's definitely less than 20. Now, here's where you get to be more creative. So those of you who are like, I'm more of a creative person than a math person. Great, this is your opportunity. What do you think might have happened to Gail between 1:30 and 3 o'clock? Yes, Emma.
She saw an animal and she stopped to look at the animal and then she realized that she was really tired, so she took a nap.
Okay, so she took an hour and a half nap. That's
Yes.
certainly
No,
possible.
she looked at the animals for 30 minutes
And then
she
took an hour nap?
And then she took a 45-minute nap and then it took her 15 minutes to get everything ready and then she
Okay, Ben.
Her bike fell in half.
Her bike fell in half?
Broken?
How did she
Yeah,
keep
just
going?
like fell in half.
Uh-huh.
She bought a new bike.
Like, no.
It took her an hour and a half to buy a new bike. Okay. Christian.
She ate lunch.
She ate lunch? Man, that's a big lunch, but yeah, it's certainly possible.
Right, it's like this, you're opening the sandwich.
Yes, Bella.
I put bike broke or got lost.
What now?
Bike broke or he got lost.
Yeah, I usually to me, and again, it's not as creative as some of your answers, but I think the most likely thing in this is, she had some sort of mechanical malfunction because she's not moving at all. Her distance isn't changing, so she's in one place for an hour and a half. So maybe a little less serious than her bike broke in half, but maybe some other kind of mechanical problem.
She got attacked to a bear.
She forgot.
Got attacked by a bear.
She forgot her helmet.
She forgot her helmet.
Yeah, and so that she had to go back.
Oh, but if she went back,
Oh, then I would have to go back already.
you'd see her distance.
Her helmet broke, so she had to sit down and she had to fix the helmet, and then she had to reapply the stickers, and then she went.
All right.
She wanted a break.
She wanted to nap.
So, last question here. If Leslie continues at her current pace, about when do you think she's going to finish the race?
7:15 down 20.
Yeah, so.
So, I'm going to try to extend that line. It helps if you have a ruler. But let's see. So, Leslie is going about like this.
If you go to 60,
Yeah, about like 7:30.
And if it's a 60-mile race,
I'm getting like 7:15 to 7:20.
that would go about there. And then this is, yeah,
Like
7:15.
7:15, 7:30,
7:27.
7:27,
Yes.
somewhere in that time. All right, are there any questions about this? This is an introduction to something that we're going to be doing. Eventually, we're going to look at, well, how can you solve a system of equations?
By solving it.
Pardon?
By doing that.
Yes, we'll be doing math.